Hi, today's presentation is about ozone, and it's a very important presentation. You're going to want to have a blank piece of um, notebook paper in front of you. There's some chemical equations we're going to write down. Feel free to stop the video, rewind it, make sure you get the chemical equations down. So we are going to learn about the creation of stratospheric ozone, the creation of tropospheric ozone, and when you're finished with this and you've studied it for a while, you can use the ozone practice sheet to see if you remember the different parts. Just only do the first two parts, the first two rows, because the last third row is about ozone depletion, and that's not covered yet. So there are some things in life that are good in one spot and bad in another, and ozone is like that. Stratospheric ozone is up in the stratosphere. That's above the clouds. That's from 60,000 feet and higher. You're never going to be in the stratosphere, and there's ozone there. There's also ozone in the troposphere, and the troposphere is where you live. That all goes all the way down to the ground, and there's ozone there as well. Ozone is ozone. Doesn't matter where it is. It's the same molecule. The molecule is O3. In the stratosphere, it's great stuff because it blocks harmful UV rays that would otherwise cause us cancer and things. But in the troposphere, it's really bad stuff. It's a secondary pollutant. And if you recall what a secondary pollutant is from yesterday's video, that is one that's made from primary pollutants and actually isn't created directly by humans. So that's made from nitrous oxides and VOCs, volatile organic compounds, with sunlight. And it's going to be a very serious lung irritant. Let's first talk about stratospheric ozone. Stratospheric ozone forms and breaks down naturally. So it gets made naturally, and then it breaks down naturally in a closed loop cycle. It's happening continuously. And the most important thing that you need to remember about it is that it absorbs harmful UV light. Without the ozone layer, a ridiculous amount of UV light would be coming in, causing all sorts of problems for us. So here's the chemical equation. You start with oxygen. This is going to be very simple. In fact, it's so simple, we're only going to ever use one kind of atom, and that's oxygen. So oxygen in the atmosphere is going to be hit by UVC. Turns out there's three different kinds of UV light, A, B, and C. So UVC, which is just a different wavelength than the other UV lights, is going to hit O2. And if you think about it, what can possibly happen to a molecule that is absorbed that absorbs some UV light? Well, it just breaks down into its component parts, which is oxygen and oxygen. Now there are free atoms, though, not very stable. Took some energy to break those apart. So one of those oxygen atoms is going to combine then with some other O2. And of course, what gets made? Ozone. And that's how you make ozone. That's a pretty simple reaction. But then what happens to ozone? Well, we already said that it absorbs UVB ultraviolet light. And what do you think happens to ozone when it absorbs light? Well, it comes apart into oxygen, O2, and free oxygen, O, just the reverse reaction. So there you have it. That is the formation of ozone and the degradation of ozone. Both happen totally naturally and continually in the stratosphere. UVB causes sunburns. That's where the B comes from, or one way to remember it anyway. So another way of explaining ozone here is, just on the side here, it's just a repeat. UVC splits O2 into two O's. O2 plus O turns into O3. And then O3 gets hit by UVB, breaking it down into O2 and O. You might wonder, whatever happened to UVA light? Well, UVA light, ultraviolet, doesn't get absorbed by anything in the stratosphere, and so that causes us premature aging and skin cancer. Nothing we can do about that except for be covered and wear sunscreen. So let's talk about tropospheric ozone, ground-based ozone. Ground-based ozone is quite a bit more dangerous. Tropospheric ozone is created, well, see if I can get this thing going again. Secondary pollutant, like we said, it's not emitted from any smokestack. We don't make it. It gets made by itself with primary pollutants. And it's formed when you have nitrogen oxides and VOCs reacting with sunlight. Okay, and it causes respiratory problems, very bad for the lungs and any sensitive surface, including plants. So we're going to draw a chemical equation for this. It's a little bit complex. We're going to need all that space. It starts with a primary pollutant, which is nitrogen oxide. And nitrogen oxide absorbs some sunlight, breaking it up into NO and O. Sort of similar to what happens to a normal oxygen atom in the stratosphere, except now there's an N attached. So it's really, if you look at it, it's almost the same reaction, except we've got that N. So that oxygen atom now is free to combine with a regular O2 molecule, and guess what it makes? It makes ozone. So there we have, our primary pollutant creating a secondary pollutant from using sunlight. But it doesn't stop there. The story continues. Because we had this NO, which is just hanging out and nothing's happening with it. That actually reacts with that ozone that was just created and forms those reactants again. So it's just the reverse reaction. So as soon as ozone is made, it's degraded. So here we have a reaction that creates ozone, and then here we have a reaction that degrades ozone. So guess how much ozone ever stays in the troposphere naturally? Nada, nothing. But when we have VOCs present, now that is a primary pollutant as well. VOCs, volatile organic compounds, kind of mess up that degradation reaction. Let's see, what could they possibly react with to prevent that degradation reaction from happening? That's right. Those VOCs are going to react with that nitrogen oxide. When it does that, it creates what is called a photochemical oxidant. Now, there are many different kinds of VOCs, so there are many different kinds of photochemical oxidants. We don't need to know that. We don't need to know the specific ones. So there's your secondary pollutant. But now, so that's already a problem. Now we have VOCs, which are a pollutant, and we have photochemical oxidants. But we also don't have that NO anymore. So what can't that NO do? That NO is too, if that NO is gone, it can't degrade that ozone, and now we're left with the ozone. So that's the tricky part about this formula, is that the ozone is normally made, but it normally degrades. In the presence of VOCs, it can't degrade. And then we get a twofer because we get what's called photochemical smog, which is a combination of ozone and photochemical oxidants. We're going to see that a lot of where these pollutants come from, VOCs and nitrogen oxides, is from transportation. So cities with a lot of cars are going to end up with a lot of smog. So ozone helped us learn about primary pollutants, right? Helped us learn about the secondary pollutants that are created. And we learned about the formation of ozone. So that's a terrific example of using all those things. And we also learned about photochemical smog. So a lot going on there. So when you've finished this and you think you can understand it, try answering the questions on the ozone practice sheet. And if you look at that, the questions on the left side are really basic. And as you go from the left to the right, they get more and more difficult. So you do that multiple times as practice. And that is it for today. If you got any questions, come talk to me in my office hours.